Welcome on PASC23 on stage. I am here with Petros Koumoutsakos, the second recipient of the PRACE Excellence Award, and with Serge Bogaerts, who is the Managing Director of PRACE. So, Serge, can you tell us what is this award about?
Yes, Margareta, as you said, it's the second edition of the award. The PRACE Excellence Award has been created by PRACE to actually reward an exceptional performance of a scientist using HPC, but actually to make science. So we believe at PRACE that we should not only focus on what HPC technology does, but also what the science we do with that. And actually, I'm very happy that Professor Koumoutsakos could actually give this talk this morning on what he did with HPC and the science he's doing with that. So I'm very happy that we see that actually science is done with these HPC machines.
Thank you, Petros, professor at University of Harvard, and before you have been 25 years at ETH Zurich. You are pluri-awarded, but what is for you? What does it mean for you to receive the PRACE Excellence Award?
It's a very special award because PRACE has been a very important part of my life when I was in Europe. I have been the recipient of allocation of time in PRACE machines. But I want to stress that it's not only the time, it's the community, it's the exchanges that we had as scientists, and I was in the steering committee of PRACE, the scientific committee. I was in the access committee. I participated in a community of great people, and that has been a great motivation and a great connection to PRACE and the people who were around it.
You gave, as usual, an inspiring talk, and in one of your messages was that we need to use machine learning with caution because machine learning will not be able to simulate flows. So now I am asking you, why do you think that there is this general ideas that machine learning is going to take over the scientific world? What is your thought about this?
I didn't say that machine learning cannot solve flows. I said that there is places where machine learning actually can complement what we already do, and can advance the state of the art in solving fluid mechanics problems. For example, in turbulence modeling, I believe the work that we have done in using reinforcement learning to develop closures for wall-bounded and homogeneous turbulent flows is the state of the art in fluid mechanics. And this has been done thanks to reinforcement learning. But at the same time, reinforcement learning is a tool. You have to learn its language, and there was a lot of domain expertise that went into how do you train the reinforcement learning. We had to decide what are the states that you use, what is the reward, what are the actions, and this made a whole difference. So I believe in this combination of seeing machine learning as an enabling tool, as combining our existing knowledge, as augmenting capacities, automating a lot of things that need automation. So I'm not saying that it cannot solve flows. There are certain flows, for example, direct numerical simulation at Reynolds number of 1 million, it cannot solve to the best of my knowledge. But that's another question than doing a turbulence model that may be of relevance to weather prediction or to aircraft design. These are two different questions. So we have a whole set of tools, and we have amazing tools now with machine learning. And now, why all the hype? Because, after all, it has been solving some challenging problems. I would call this closure of turbulence as one big challenge. There is AlphaFold, there's a lot of different exciting things. It's a new modality for discovery. And also in my talk, remember I said in scientific computing we had these ideas of mathematics, mathematical forms, we had exactness, and we had understanding. Now we have these other ideas where there is architectures, which is modular, and you can combine. Then you have statistical inference, which is another mode than 10 to the minus 6 accuracy, and you have goal-oriented research, which is we have a wealth of combinations that we have now. So it's exciting.
Scientist that comes to this business and they want to start to do simulation and science and computational fluid dynamics, where should they be careful when they use machine learning?
To try to state what are the challenges and what are the things that they don't work together with the things that work. One has to be honest. One has to do validation and verification like we always did. One has to do uncertainty quantification about every model you use. You should say what is the uncertainty of its predictions. So all the old stuff, I think it's applicable also to machine learning, but it requires a little bit a different methodology, because how do you do uncertainty quantification for machine learned models is not a trivial task. Validation also may be difficult, but the danger is that people forget about validation, verification, and they just show results and beautiful colors, and I think that would be a disservice to advance in machine learning itself, because there is a lot to be advanced there.
So will machine learning ever replace human imagination?
Human imagination replace it? No, I would say. I think these are two different things. I mean, at least the way machines we have today, they are digital machines. I don't think they operate as the human brain. I don't know if there is a gut feeling in a computer. An artist usually has a gut feeling. An artist has experiences. A machine creates some kind of an average from experiences or data that you feed in. I think it can help the human imagination. So if I go to ChatGPT and I say, please give me a story about this X, Epsilon, Z, maybe it would be an interesting story, and then it can help the human imagination. But replace, I don't think it's the right way to think about that. Maybe it will replace certain tasks that can be automated, and that would be very welcome. But I think it's a synergy that is evolving. It's exciting.
So AI will not yet take over the world.
AI take over the world? I don't know what you mean by that. But,
no, sure.
I mean, it's exciting because, you know, computers also have become so powerful that AI was always there.
Yeah.
I can show you, there is a video from 1960s. There is an interview, there's Claude San on there, there's all the pioneers of AI, and the questions are all the same, except it's what I said in my talk. In 1997, when I was training neural nets, in a supercomputer, a neural net that today takes 2 minutes, back then it will take a year. And that's huge difference. It's a huge difference.
Serge, what is your final word about the Petros talk and also the PRACE vision on the future?
My final word would be thank you, Petros. Thank you for the inspiring talk, for your ever pushing attitude in pushing people in doing good things. So thank you for that, really.
And thank you very much for the award. Appreciate it.
Thank you.